Okay, hope you're having a great day today, and I will do a quick video here on right triangle trig. Okay, and we'll be finding lengths of sides and measures of angles in right triangles. Okay, just as a quick refresher from your geometry, this is basically very similar to your geometry lesson last year. Um, we're going to go through here. I'm going to make this, if I make this angle here in a right triangle, one of my acute angles. Now, from here, this is the opposite and this is the adjacent. This is always the hypotenuse. Now, if I talk about this angle over here, now this is the opposite and this is the adjacent. And we know our SOHCAHTOA. So we've talked about this a little bit this year. So sine equals opposite over hypotenuse. So cosine equals adjacent over hypotenuse. And tangent equals, TOA, TOA equals, that's the tangent, and that's opposite over adjacent. And again, the condition is we have a right triangle and a right triangle, and we're talking about sine, cosine, tangent. Okay, so let's get started here. Change this up a little bit. What you really need in your notes is the picture should be sufficient. You're at the Washington Monument, and you look from where you're looking, which is point A, to the top of the Washington Monument, point B, is that angle is 27 degrees right in there. Okay, so we want to find approximate distance from A to C, from where this person is to the tower, along the flat ground. We're assuming the ground is flat, so forth and so on. So basically, we play the game of what do we have and what do we want. We have the opposite. We want the adjacent from the 27-degree angle. Okay, from the 27 degrees, if you put your thumb at 27 degrees, the 555 is opposite, and A to C is adjacent. So we'll call that X. So we set up the tangent ratio of 27 degrees is equal to the opposite over the adjacent, which is equal to the 555 over X. And we'll get our answer in feet. So in our calculator, we get basically tangent of 27 degrees. Make sure you're in degrees times X equals 555 degrees, or 555 feet, times 1 when I cross multiply. Okay, so X equals 555 divided by the tangent of 27 degrees. We'll go ahead and put that in our calculator real quick. Oops. All right. Okay, so I make sure I'm in degrees. Yep. Quit out of there. And I have the 555 divided by the tangent of 27. You get 1,089. Okay. Feet to the nearest foot, 1,089 feet. Okay. And now in the book, this answer right here, they round to the hundredths place for the tangent, which isn't very common. Usually you're going to round to 4 places if you do round, but in our calculator, if you put it in, you'll get your best answer by just plugging it in that manner. Okay? Okay. Now let's look at a triangle here where we have, so we need to be able to draw these triangles. So triangle PQR. So it doesn't matter how you scale it. I'm going to go ahead and there's a 7 and a 25, so there's something that's a little bit shorter, and that's going to be P to R. Okay, and This is going to be Q here. So it says the cosine of angle P, which is right here, is 7 over 25. So I put those sides in there. That's my adjacent over my hypotenuse. Okay. So I do Pythagorean theorem. I want to find little guy P right here. In other words, across from the angle is always the side labels. So P squared plus 7 squared equals 25 squared. P squared equals 25 squared minus 7 squared, and that's 576. So take the square root, and P is 24. Okay. Hopefully you kind of vaguely remember that maybe from geometry last year. That's a Pythagorean triple, meaning that all three numbers are whole. Okay. And then for the last thing there, they basically the question. Now that I've got all the sides labeled, I can answer the question. Sine of P equals 24 opposite over 25. Tangent of P. Tangent of angle P equals opposite 24 over 7. Okay. And lastly, I get cosine Q. So for Q, I'm going to go up here to angle Q and say from that green angle there, the adjacent is now 24, the hypotenuse is still 25. So the cosine Q is 24 over 25. I'm not going to bother putting that into decimal form. You just leave that in the fraction form, and I'll be more than happy with that. All right? Okay. Let's go ahead and keep moving here. Let's go ahead and work the problems, which is really what this is about, finding these problems. A man is 6 feet tall. Okay, so there's 6 feet there. And he's standing 50 feet from a tree. So from his eyes across the tree is 50 feet here. When he looks at the top of the tree, the angle of elevation is 42 degrees. So here's the treetop up here. Okay, there's the tree-ish. Okay, and we want to find the height of the tree from all the way up here to all the way down there. Okay, so I've got a right triangle right in here, in black here. There's my right triangle. Okay, I got 50 here, I got a right angle here, and I need to know the angle of elevation means from the man's eyes up is 42 degrees. So the horizontal line from the guy's eyes up is angle of elevation. Vocabulary. Angle of elevation. Got to know that word. So now for this black line here, let's call this Y right here. We can find that using, well, let's see, what do we have? What do we want? We have the adjacent. We want the opposite. So I'm going to use tangent. So the tangent of 42 degrees equals the opposite, which is y, unknown, over 50. That's a beautiful thing because we can just multiply that quickly. And we get y is equal to, when I cross multiply there, I get about 45, approximately. And that's in feet. Now we got to make sure we answer our question. The question is find the height of the tree. So basically I got to take the y, the 45, plus the 6 feet of man, and I get 51 as my final answer, approximately. The tree is 51 feet high. All right? So basically this is really what we want to be able to do. We want to be able to take pictures and insert right angles and be able to find sides and angles. Okay? All right, let's go to the other direction. Now we've been finding sides given angles. Now we're going to be given a ratio, find the angle. Okay, so for this guy right here, my picture, again, doesn't matter your scale. You put K, I put K, N, and then M. All right. And in this case, angle N is the right angle, and M is 7. So across from this must be 7 here, and N is 25. So my hypotenuse is 25. So find angle K is my question. Okay. So we can do this pretty quickly. We can say to basically our calculator, this is, well, I have a ratio. I can say the cosine of angle K is 7 over 25. And I say to my calculator, hey, Mr. Calculator, in a right triangle, if the ratio of cosine is blank, can I get that angle? Yes, you can. You do the inverse. So I take basically the inverse of both sides. Okay, and these basically cancel out, and on the left-hand side, I get angle K equals the inverse. So in my calculator, I'll show you how this goes. In your calculator, you go second cosine. You say, hey, Mr. Calculator, the ratio is 7 divided by 25. And you say, what angle goes with that in a right triangle? And your calculator says, well, that angle must be, angle K must be 73.7 degrees. And by subtraction, we can go ahead and find, if they wanted angle M, we could subtract from 90 and get that as well. Okay? But that's your basic process of, given a ratio, find the angle. Okay? So let's work a problem with this, and we'll be done. All right? The straight road goes up a hill 800 feet higher than at the top than at the bottom. So the road goes up the hill like this. And we're 800 feet higher at the top than the bottom. So basically, we're talking about this right here is 800. And it says the horizontal distance is 6515 in feet. Everything's in feet, so that's good. I got a right angle right there. To the nearest degree, what angle does the road make with the level ground? So right here is what they're asking for. Okay, so being able to draw the triangle given the paragraph is a skill. Okay, so theta is unknown angle, right? So now this theta here, I got, what do I have here? Let's see, I have an opposite and I have an adjacent. Well, that makes tangent, and that's really the question that I need to have answered. So the tangent of theta equals 800 over 6515. Okay, so now I'm going to do that inverse idea again. Get this out of the way here. Oops. Okay, and again, I say to my calculator, hey, Mr. Calculator, in a right triangle, if my tangent ratio is 800 over 6515, what angle does that come out to be? So you go to your calculator, and you go second tangent. Again, make sure you're in degrees. Plug in your numbers. 800 divided by 6515. And it'll tell you in a right triangle if, oops, I didn't push inverse, did I? Okay, so second tangent. Did I get the second? Yep. Second tangent. 800 divided by 6515. And basically you're saying, hey, if the tangent ratio is 800 over 6515, what's the angle? That's why the inverse is there. Right at 7 degrees. Okay. So what can we do today? At the end of the day, we can basically, in a right triangle, given a side and, given some information, we can find a side, and given two of the pieces, we can find an angle. Hope this finds you well, and hope you're having a great day.